Hi everyone, Miss Cox here. We are going to work on part whole and two-digit addition today. So I wanted to show you what part whole look like, and I want to give you a really neat strategy for adding numbers that have more than one digit. So the first thing that I want to do is I want to show you what part whole looks like. So you know the house roof that we've been working on, and it's got a parent number up here and two children number down here. P for parent, C for children. This is going to be similar to what you're going to see on a part whole. This diagram right here is a part whole. What you're going to see up top, or even just in the bigger section, this section right here, all of this right here, it is the parent. So this is the total, or the whole. It goes all the way from this end to this end. And then the children numbers are the ones that are down here in this one and this one. So just like we would have it here on our roof, it's going to be in our part whole. Okay, so for the number that we did for, what's it called? Our morning meeting for Friday is 21 is what we figured out after we added 9 and 12. 9 and 12. So 9 and 12 are our children number, and 21 is our parent number. Okay, so if I gave you 3 and 2, they're both children number. The question mark would be up here, which means I need to find the parent. And when they are side by side, look at that, I just made a plus sign. When they're side by side, I add them. So I would add them like this. Or if I gave you the 5 but didn't give you the 2, if they're stacked, you must subtract. So just like over here, if I have a parent and only one child, if I have a parent and only one child, they're stacked, so I subtract, and I would find the other child. So if they're stacked, you must subtract. 5 minus 3 equals 2. So that's how we look at part whole. So now I'm going to give you some numbers in a part whole format, and then I'm going to show you a really neat way to add and subtract double-digit numbers. Okay, so if I give you, I'm going to make this a little bit bigger and probably where you can see it. I'll give you my parent number, or sorry, children number. I'm going to give you two children number. We're going to add first. Okay, so if they're side by side, we add. The reason why we work so much on place value is because whenever we get into adding and subtracting, it is very, very important that you line up the place value. So we can write it like this, or until we get better at it, I would like for you to set it up in square format. We're adding. This is the tens place. This is the ones place. So I have a 10 here, and 3 in the tens place here, and a 6 in the ones place here. And then here I have a 2 in the tens place and a 1 in the ones place. So now I have that 36 plus 21 nice and neat and organized so that I can add them without getting mixed up. All right, so now on to how I want to show you how to add these. Let me get another board so we can come back to this. Okay, so 36 represented in base 10 blocks will look like this. 21 will look like this. So the first thing we're going to do is we start at the ones place. This is our starting mark, and we go left. So we start at the ones place. So we're not even going to look at the tens yet. 6 plus 1, we have 6 plus 1 more is 7. Now we can move on to the tens place. We have 3 tens plus 2 tens is 5 tens. So 36 plus 21 equals 57. So on our part whole, we would add it in like that. So let's try a different one. I don't like erasing with my finger. And I keep putting my eraser down. Well, I hid it from myself. Okay. It gets messy. Yeah. Okay. Let's do another addition problem. Probably should. Let me see. I'm making it messier. All right. Let me try this one more time. $53 plus 16. So 53, 5 in the tens place, 3 in the ones place, 16, 1 in the tens place, 6 in the ones place. So to represent 53, I would say 5 tens, 3 ones. 16, 1 10, 6 ones. So I start with the ones place. I'm adding the dots first. 1, 2, 3 plus 6, 4, 5, 6, 7, 8, 9. And then I add the tens. 1, 2, 3, 4, 5 tens plus 1. 10 is 6 tens. So 69. 69 would be our whole. And remember, we've practiced figuring out greater than and less than and how we can do that. The greatest size box is going to be our biggest number. And then the 2 smaller numbers go in the other boxes. In fact, if we use a strip diagram and we wanted to make this even more accurate, we could actually make it look like this. So in relation or in comparison to the numbers, all of these are accurate sizes. In a strip diagram, the whole is still the whole bar. The parent is still the whole bar, but the 2 parts added together equal the parent. Just one might be smaller than the other. 16 is much smaller than 53, but the 2 of these added together still is 69. So let me do a subtraction problem. All right. All right, so if we're doing a subtraction problem, they're going to be stacked in our part whole. So we'll start with 78 minus 21, and we're going to find this other child. So what would be different here is a subtraction sign. We will still work from the ones place to the left, and we'll still use our base 10 over here to help us subtract. So in order to represent 78, put a 7 here in the tens place and an 8 in the ones place, 2 in the tens place, 1 in the ones place. So 78 represented over here in base 10, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. 78. And then 21 looks like this. So what I'm going to do is focus on the ones place first. Again, I have 8 ones, and I'm going to minus 1. If you're using a pencil and not a marker like me, we would just cross it off. How many do I have left over? Well, there's 8 left over. Or sorry, 7. Let me try that again. That's my rewind sound. We won't cross this one off. We're going to take this amount away from this. So we'll cross this one off. 8 minus 1, and I'm sorry if I confused you. 8 minus 1 is 7. 1, 2, 3, 4, 5, 6, 7. Alright, and then 7 tens, I'm taking this amount away from here. So I cross off 1, and then I cross off 2. I have 1, 2, 3, 4, 5 tens left. 57. So 8 minus 1 is 7. 7 minus 2 is 5. 57. Let's do one more subtraction, actually, because I may have confused you by talking too fast and confusing myself. All right. Think of a number. 39 is our whole. 17 is one of our children, and we're trying to find the other one. So we put 39 here, 17 here. And to represent that, I write 1, 2, 3 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9. 17. 1, 2, 3, 4, 5, 6, 7. All right. So we start on the ones place. 9 minus 7. So I'm going to cross off 7. 1, 2, 3, 4, 5, 6, 7. And I'm left with how many? 2. Then we move on to the tens place. I have 3 tens minus 1 10. So I'm going to subtract this. 1. And I have 2 tens left. 22. 39 minus 17 is 22. I hope that was better. All right, and that's all I have for you for today. Thank you guys, and I'll talk to you later.